So we're in section 1.7. We're going to talk about midpoint and distance. So let's remember what we mean when we're talking about a midpoint. So what is the midpoint? What's special about the midpoint? What are we even talking about when we say midpoint? Well, what does the word tell us? Yeah?
It's a point in the middle of a line.
Point in the middle. So the midpoint is the point in the middle. So what does that midpoint, what does a point in the middle do to a segment? Yeah?
It cuts the segment in half.
Cuts it in half. And I'm going to just say it in a slightly different way because that's how we end up calculating it. It's halfway between the endpoints. So if we have a number line, here's a number line. And we have, let's say one end of my segment is at -3, and that's one endpoint of my segment, and the other endpoint is at 7. And we wanted to find the midpoint. What would we do? What is it? 7 minus 3? That gets us partway there. Well, how far is it from -3 to 7? How many units? Let me put some more points here. -1, 0, 1, 2, 3, 4, 5, 6. So how far is it from -3 to 7 on the number line? 10 units. And we want the point that's in the middle. So 10 divided by 5 is 2. Or sorry, 10 divided by 2 is 5. So we need to go 5 units from either endpoint. So 1, 2, 3, 4, 5, we get to 2. Or if we go 5 units, 1, 2, 3, 4, 5, we get to 2. So 2 is the midpoint. It's 10 units between them. Half of 10 is 5, so we have to go 5 units from either one to get to the midpoint. Now, if these numbers are bigger, instead of -3 and 7, we had 3,852 and 7,576. What we did with the counting is a little more difficult. Or if our endpoints are fractions, we have fractions for our endpoints or some kind of decimals, it gets a little more difficult. But there's an easy way to do it. The middle is the average. So the middle between two numbers is the average. And that's how we're going to calculate midpoint. So we can say our midpoint is 7 plus -3 divided by 2. Add the two numbers together and divide by 2. Well, 7 plus -3 is 4 divided by 2 is 2. And that gives us our midpoint. Our midpoint is the average. Yes. Yes. All right, so if we're in the plane, though, and not on the number line, there's a little more to it, but just a little more. So there are my axes, and I'm just going to put a segment in the plane here. So some generic segment. And I'm going to say that's point A and point B. In the plane, we need two numbers for my midpoint. We need an X and a Y. To talk about my midpoint. Well, what we're going to do is find the average of the X's and the average of the Y's to find the midpoint. So we're going to average X's and average the Y's. So the way that we usually label our points in the plane, I'll call that point x1, y1, and this point x2, y2. So our midpoint, we usually use capital M for midpoint. We're going to add the x's, x1 plus x2, divide by 2. That gives us our x coordinate of our midpoint. And we're going to add the y's, y1 plus y2, divided by 2. And that's going to give us our y coordinate of our midpoint. So we get an x and a y. Average the x's, average the y's. All right, questions? Okay, let's look at a couple of examples. So you might be given the coordinates of the endpoints just verbally. The endpoints of a segment are such and such and such and such. You might be given a graph, and it'll say find the midpoint of the segment. Somehow you'll be able to figure out the coordinates of the endpoints. So let's say we want to find the midpoint between, I'm just making these numbers up, 2, -5 and 3, 7. So what I suggest you do is label your points. So I'm going to call this one x1, y1, and this pair x2, y2. Doesn't matter which ones you call the ones or the twos, but the ones and twos have to stay together. You can't mix the ones and the twos. And I'm just going to plug these numbers in to my midpoint. The midpoint is, we add the two x's. x1 is 2 plus x2 is 3 divided by 2. That gives me my x. And add the y's. y1 is -5 plus y2 is 7 divided by 2. That gives me my y. And 2 plus 3 is 5 divided by 2. So I can write it as 5/2. You can leave it written as a fraction. We could write it as decimal if we wanted. And -5 plus 7 is 2 divided by 2, which is 1. So the midpoint of that segment would be the point 5/2, comma 1. Yeah. For a midpoint, yes. Because we're finding the average. To average numbers, you add them together and divide by how many you have. All right, questions? Yes?
Does it really matter if you write it as a decimal or a fraction?
No, it doesn't matter. Probably if you needed to graph it, it would make more sense to write it as a decimal than the fraction. All right, let's look at a slightly different example. For the next example, we don't know one of the endpoints. We know the midpoint and one endpoint, but not the other endpoint. So the midpoint of segment LM is 2, -1. One endpoint is, we're going to say point L is -3, -5. We want to find the other endpoint. Find the coordinates of M. So we don't know what that is. I'm just going to call it X and Y. We don't know what they are. When math, we don't know what things are. We call them X. We don't know what the Y coordinate is, so let's call it Y. I'm going to do this problem the same way that we set up the last one. I'm going to label my two endpoints. I'm going to call this point x1, y1, x2, y2. Those are my two endpoints. And this 2, -1 is my midpoint. So from our midpoint formula, we know that 2, -1 equals the average of the x's, x plus -3 divided by 2, x1 plus x2 divided by 2. I'll write it the other way around. x1 plus x2, -3 plus x. And the y coordinate for my midpoint is y1 plus y2. We don't know what that is, so I'm just going to call it y, divided by 2. Well, now we have two pieces that we can work with. We have the x part. I'm going to circle it in green there. And we have the y part. I'm going to circle it in blue. We use one piece for the x's and one piece for the y's. So for the x part, I have that 2 has to equal -3 plus x divided by 2. And for the y part, I have that -1 has to equal -5 plus y divided by 2. And I'm just going to solve each of these. So here, what on this the x part, what do I do to get rid of this 2 in the denominator? Multiply everything by 2. On the right-hand side, the 2's cancel, and I get that 4 equals -3 plus x. Add 3 to both sides, and I get x equals 7. And I'm going to do the y part the same way. Multiply by 2 to get rid of that fraction, that 2 in the denominator. And I get -2 equals -5 plus y. Add 5. And I get y equals 3. So my midpoint, or sorry, my endpoint is the point 7, 3. So we set it up exactly the same way as we did the last one. We just have an x and a y that we have to find. All right, questions there? Okay, the last thing for today, distance. When we're using the distance formula in geometry, usually we're going to be finding lengths. So we have the coordinates of the sides of a triangle or sides of a rectangle or something, and we want to know how long the sides are. When we have coordinates, length means use the distance formula. So let me draw a picture again. Same setup as we talked about with the midpoint. We just have some point in, or some segment in the plane. There's an A and a B for my endpoints. I'm going to call this one x1, y1. just like we did before. X2, Y2. And what we're doing here, just so we have an idea, is I'm turning this segment, if I bring this straight down and this straight down, I get a little right triangle there. The distance formula is the same as the Pythagorean theorem. We're using the Pythagorean theorem to find the length of that side of the triangle. That's what the distance formula is. So we're going to say the distance between x1, y1 and x2, y2. We usually use a little d for distance. The square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And what that is the Pythagorean theorem on this little triangle. So that's how we would find the length of that side. All right, so let's look at an example of calculating distance. Now I want to point out, for distance we get one number. For midpoint we ended up with an x and a y. For distance we just get one number. So I want to find the length of the segment between -3, 6 and -4, -3. So we have a segment in the plane between these 2 points. They might give you the points. The problem might give you the points. They might have the segment graphed. You might have a graph, and you need to look at the graph to figure out the coordinates of the endpoints. So I'm going to suggest you do the same thing with this. Label your points, x1, y1, x2, y2. Doesn't matter which ones we call 1s and 2s, but the 1s and 2s have to stay together. You can't mix the 1s and 2s. And I'm just going to plug these into my distance formula. The distance is the square root, x2 minus x1, -4 minus -3. And we're squaring that. Plus y2 minus y1, -3 minus 6 squared. Yeah. No, x2 minus x1, y2 minus, so we added for the midpoint formula, we subtract for the distance formula. So let's do our arithmetic. The square root of -4 minus -3, -4 plus 3 is -1 squared, plus -3 minus 6 is -9 squared. And here's where we need to be careful with the distance formula. When we square things, we always get a positive number. So once you square things, there should be no negatives in your distance formula. So this equals -1 squared is 1, plus -9 squared is 81. So get the square root of 82. And that should be just a little bigger than 9. So I plug that in my calculator, square root of 82, and I get about 9.01. Rounded to the 100th. So the length of that segment is just a little more than 9 units. All right, questions on our distance formula? So the big thing to remember when you're using the distance formula, once you square everything, you should end up with no negative numbers under your square root in your distance formula. Okay. There's that.